An American company walked onto a stage in Seoul and unveiled a tiny part made of glass. 2 days later, half a world away, optical communication stocks across Asian markets collapsed. Hundreds of billions in market value, gone in a single day. Some stocks locked limit down. But here's the strange part. On that very same day, a different group of stocks, the ones with glass in their story, shot up. Some hit limit up, same piece of news. Some people running for the exits, others scrambling to get in. And all of it may come down to one English word being read the wrong way. Corning said complement. The market heard replace, one word, a few hours. Hundreds of billions wiped out. So what is this little piece of glass, really? And what does it actually replace? First, the company. It's called Corning. They make glass, and they've been doing it for 175 years. Your phone screen, the glassware in a lab, the fiber under the ocean. Corning is probably somewhere behind all of it. But what set the market on fire this time wasn't the glass itself, it was a location, the doorway where light enters an AI chip. Today's AI workloads move so much data that copper wiring can't keep up, so the industry is switching to light. The problem is, light coming in from an external fiber has to get into the chip's internal light path, and there's a checkpoint in between. That checkpoint is called coupling. Sounds minor, right? But for the past 3 years, whether AI optics could be mass-produced at all came down to this one step. And what Corning unveiled is meant to solve exactly this doorway. To understand what the market was fighting about, you first have to see why this doorway is so hard. The heart of the problem is a mismatch in size. The light path inside a chip is only a few hundred nanometers wide. The fiber coming in from outside has a core that's 9 micrometers wide. That's a difference of dozens of times. Here's a way to picture it. The fiber is like a thick water pipe. The light path inside the chip is like an ultra-thin capillary tube. Connect the thick pipe straight onto the thin tube. What happens? Water sprays everywhere at the joint, and most of it leaks away. Light behaves the same way. Connect them directly, and a huge share of the optical signal scatters and leaks out. The signal weakens, so you can't just join them. You need something in between to guide the light smoothly, from the wide end down to the narrow end. How you build that transition is the technical heart of this whole story. The industry's mainstream approach has a name, FAU, Fiber Array Unit. The idea is this. You take several fibers and, using a very precise machine, actively align them onto the chip one by one. Once each one is locked in, you fix it in place. It works, and it's still the standard today. But it comes with 3 headaches that get worse as AI demands more. First, it's slow and the equipment is expensive. Active alignment means a high-precision machine has to calibrate each fiber individually. That step takes time, and the gear that does it doesn't come cheap. Second, it gets hard to scale when the fiber count climbs. The next generation of AI optics needs an enormous number of channels packed into a tiny space. Aligning them one by one, the assembly gets more and more complex, and the density runs into a ceiling. Third, it isn't built like a semiconductor. FAU is fundamentally an assembly process, pieces put together one at a time. It doesn't get made the way chips do, in massive parallel batches on a wafer. And that, as we'll see, is exactly the gap Corning went after. Hold that third point. It's the key to the whole story. Corning's idea is different. Instead of aligning fibers one by one, they make a single piece of glass that lets the light transition smoothly on its own. That piece of glass is the glass bridge. Inside it, a gradual light path is pre-built, wide on one end to meet the fiber, narrow on the other to meet the chip, with a smooth taper in between. Back to our analogy. FAU is about carefully aligning the thick pipe onto the capillary tube. The glass bridge, instead, is a single funnel, thick at one end, thin at the other, so the water flows in and narrows down on its own, without leaking. And the way it's installed matters even more. The fiber doesn't need active alignment. You drop it into a groove etched on the glass, press it into place, and it's positioned passively. It's also designed to be detachable and reworkable, which makes servicing and testing easier as systems scale. So what does it actually replace? This is the single most important sentence in the video. It replaces the small stretch of fiber array inside the package that handles the handoff. It does not replace the entire transmission fiber running outside. Here's the everyday version. You're renovating your house. You swap your wall outlets from brand A to brand B. The outlets change, but not a single wire inside the wall is removed. The glass bridge swaps the connector at the interface, not the wiring itself. The outside fiber? Still needed, and needed even more than before. That distinction is the key to the entire market misread that follows. Surely the idea of burying a light path in glass is something others could copy? Easy to imagine, hard to make. Corning's real barrier is in how it's manufactured. They use a process called wafer-level ion exchange. Put simply, an entire glass wafer is bathed in hot molten salt, letting specific ions seep into the glass and change its refractive index, growing a light path directly inside the glass itself. What's the difference? The old way is a worker, with equipment, aligning and bonding fibers one at a time. Corning processes an entire wafer at once. A single batch can yield thousands of glass bridge components. This turns precision mechanical assembly into semiconductor wafer manufacturing. Yield, cost, and scale, those become a different order of magnitude entirely. So compared to the old FAU, the glass bridge brings 4 real differences. First, lower optical loss. The gradual light path lets the signal transition smoothly, so less of it leaks away, which means the whole system runs cooler and uses less power. Second, higher density. You can pack far more optical channels into the same space, exactly what the next generation of ultra-high bandwidth switches needs. Third, it scales like a chip. Because it's made at the wafer level, production scales the way semiconductors do, in parallel batches, instead of one assembly at a time. That's what unlocks the volumes high-density optics will eventually need. Fourth, it assembles faster. Passive alignment removes the slowest step, calibrating each fiber by hand, so assembly speeds up and yield climbs with it. Lower, denser, scalable, faster. Those 4 words are what the market was really repricing that day. Now that you understand the technology, let's go back to that crash. The market's panic logic went like this. The glass bridge is going to replace FAU, fiber is going to be obsolete, the whole optical supply chain has to be repriced. So everyone ran for the exits. But 3 things got lost in the panic. First, what it replaces is extremely narrow. The glass bridge only targets the next generation of the very highest density optical scenarios. The vast majority of optical modules out there and the long-distance links between server rooms still run on FAU, and Corning itself is still expanding FAU production. Second, the timing is far off. This is a new wafer-level process. It still has to clear customer qualification and get designed in by the cloud giants, at least another year or 2 before it ships at scale. Why should something 2 years out make stocks crash today? Third, and this is the strongest point, the companies that understand AI compute best are locking down Corning's fiber capacity with real money right now. Meta signed a multi-year fiber supply agreement worth billions. NVIDIA didn't just partner with Corning, it invested through a warrant deal and committed to push U.S. optical connectivity capacity sharply higher. Amazon committed to a production deal worth billions of its own. If fiber were really about to decline, why are the companies that understand AI best racing to lock up Corning's fiber? Come back to that misread word. Complement. The glass bridge swaps out one small connector inside the package, while the fiber outside is still needed, and with more high-density gear coming, needed even more. The market heard replace and turned a part that grows the pie into a killer, come to harvest the whole supply chain. And don't forget, the one that crashed that day wasn't Corning. Corning is the one making the announcement, the one that benefits. The panic hit the group. The market merely assumed was about to be replaced. So was the market simply wrong? It's not quite that simple. Take the side that gets diluted first. The panic got the timing wrong, but the direction may not be entirely wrong. Over the long run, in the very highest density next-generation scenarios, wafer-level approaches like the glass bridge do have a real shot at gradually becoming the mainstream, squeezing traditional FAU out of that high-end slice. And in fact, on the day of the crash, money fled optical components and poured into glass material stocks. The market was already voting with its feet, shifting value away from passive fiber parts towards specialty glass. That direction isn't coming from nowhere. But here's the part the panic completely skipped. Right now, the glass bridge isn't even the cheaper option. It's still in small volume validation, And at this stage, the cost per piece is actually higher than a traditional FAU. Its cost advantage is a future tense, not a present one. It only shows up once wafer level production scales years from now. So the idea that it's about to gut the supply chain today gets the clock wrong by a wide margin. Now take the side that grows. By clearing the mass production bottleneck, the glass bridge could actually let high-density optical engines scale up faster. When supply is no longer the constraint, the downstream feels safe enough to expand and place big orders, and the whole pie may not shrink but grow. And every higher density box needs more external fiber channels, not fewer, which is exactly why the giants are racing to lock up fiber supply. Two forces, pulling in opposite directions. One dilutes the value of a single link in the chain. One grows the entire market. Which force dominates the next chapter? That's still an open question. The panic will fade. What's worth remembering is what the people who actually read the technical documents saw once the panic cleared. Worth watching closely, not worth rushing to a conclusion on.